The story of Vazhani begins far before the dam itself, in the deep time of Earth's shifting continents. When the supercontinent Pangaea held together all the landmasses of the planet, Kerala's rocks were part of its southern half, Gondwana. As Gondwana began to fragment, India, Madagascar, and Africa were bound together in a single crustal block, the granulites and charnokites sharing the same ancestry. The southern granulite terrain of Kerala, where Vazhani now lies, was continuous with the Rhinosaura shear zone of Madagascar and the Mozambique belt of Africa. These ancient rocks, formed billions of years ago, were reworked through tectonic collisions and metamorphism, and they became the foundation upon which rivers, forests, and human settlements later grew. As Gondwana broke apart between 120 and 90 million years ago, India drifted northward, carrying with it the crystalline basement of Thrissur and Palakkad. The uplift of the Western Ghats tilted the land, reversing drainage patterns that once flowed eastward into the Proto-Amaravati and Cauvery systems. The Palakkad Gap, a great tectonic weakness zone, became a corridor through which rivers and cultures moved. In this tilted landscape, rivers like the Manali and Ketcheri were born in the Machad Mala uplands, flowing east and west from the same watershed divide. The Bharathapura, or Nila, gathered waters from both sides, flowing northwest to Ponani, while the Ketcheri River carried its waters westward to Chetuva Lake in the Arabian Sea. This dual drainage pattern is the physiographic signature of Vazhani's hills, where the land itself speaks of ancient tectonic shifts. The Vazhani Dam, built across the Vardakantri River in 1962, is nestled in these uplands. It is an earthen dam, nearly 800 meters long, framed by the peachy Vazhani forests that form the western extension of the Nelliyampathy Parambakulam highlands south of the Palakkad Gap. Its reservoir gleams like a mirror, reflecting the ridges of Machad Mala, where evergreen forests, bamboo groves, and rosewood trees thrive. The dam is not only an irrigation project but also a symbol of Kerala's ability to harness its rivers while preserving the sanctuaries around them. Vazhani's waters irrigate thousands of hectares, sustaining agriculture in Thalapilli Taluk, while its forests shelter wildlife and protect the watershed. Standing at Vazhani, one can trace the hydrological link northward to Thiruvilwamala, the Inselberg-like hill rising above the Bharathapura. The Gayatri River, fed by Manali and Vazhani tributaries, joins the Nila at Metsatha, directly opposite Thiruvilwamala. This confluence is a meeting point of geology, hydrology, and culture. On the southern bank, Machad Mala ridges cradle the Vazhani Reservoir. On the northern bank, Thiruvilwamala stands as a solitary massif, overlooking the valley. Together they form a cross-section of Kerala's landscape, uplands feeding rivers, rivers carving valleys, and isolated hills marking the opposite rim. The beauty of Vazhani is not only in its waters and forests but in its place within this larger story. Its ridges are fragments of Gondwana, cousins of Madagascar's crystalline belts and Africa's granulite zones. Its rivers echo the dual drainage of Madagascar's uplands, flowing east and west from the same divide. Its forests preserve botanical lineages that mirror those of Africa and Madagascar, with rosewoods and ebonies standing as living reminders of a shared Gondwanan past. Vazhani is thus both a local sanctuary and a global geological witness, carrying the memory of continental drift in its rocks and rivers. By the mid-20th century, before plate tectonics was formally accepted, geologists already suspected these connections. In the 1950s, scholars compared Kerala's charnokites with those of Madagascar and Africa, noting their mineral similarities and structural continuities. By 1959, Gondwana was still a hypothesis, but field evidence from Vazhani's uplands, Madagascar's Rhinosaura zone, and Africa's Mozambique belt was being actively studied. The dam itself, completed in 1962, became part of this modern landscape, a human intervention built upon rocks that had traveled across oceans in deep time. Today, when one travels along NH 544 through the Palakkad Gap, the connection becomes tangible. The highway cuts through the great corridor that once linked Kerala's rivers eastward to the Amaravati and now channels them westward to the Arabian Sea. From the road, one can see the ridges of Nelliyampathy to the south, the plains of Palakkad to the east, and the uplands of Thrissur to the west. Vazhani lies within this physiographic arc, a reservoir framed by forests, a mirror of Gondwana's legacy. This video on Vazhani Dam cannot show this layered story: the shimmering reservoir, the green ridges of Machad Mala, the wildlife of Peachy Vazhani Sanctuary, and the confluence at Metsatha. But beneath the beauty lies the deeper commentary. From Pangaea to Gondwana, from continental drift to the 1960s, from Proto-Amaravati eastward slopes to the present westward drainage, Vazhani embodies the geological and cultural journey of Kerala. It is a place where local landscapes meet global histories, where a dam built in the 20th century rests upon rocks billions of years old, and where rivers carry the memory of continents that once were joined. This is the essence of Vazhani, a sanctuary of beauty, a reservoir of life, and a witness to Earth's grand narrative, stretching from the age of supercontinents to the modern highways of Palakkad. Not exaggerated. Check out details for errors, please. Continental drift is one of the most profound forces that has shaped both the surface of the Earth and the diversity of life upon it. Around 250 million years ago, all land masses were united in the supercontinent Pangaea. By the Jurassic period, roughly 180 to 160 million years ago, Gondwana began to fracture, setting India, Madagascar, Africa, South America, Antarctica, and Australia on separate journeys. This slow but relentless movement of tectonic plates created new oceans, raised mountain chains, and altered climates, laying the foundation for the biodiversity we see today. As Gondwana broke apart, Africa and South America drifted away from each other between 135 and 110 million years ago, forming the Atlantic Ocean. Around 120 to 100 million years ago, India separated from Madagascar, beginning its rapid northward drift. This event left Madagascar isolated, allowing its flora and fauna to evolve in unique ways, producing lemurs, baobabs, and reptiles found nowhere else. India, meanwhile, carried Gondwanan lineages northward, preserving ancient plant and animal groups in regions such as the Western Ghats. By 55 to 50 million years ago, India collided with Asia, uplifting the Himalayas and intensifying the monsoon system that sustains the rainforests and rivers of southern India. Later, between 45 and 35 million years ago, Australia broke away from Antarctica, drifting into warmer latitudes where marsupials flourished, while Antarctica froze into a polar ecosystem. The biodiversity outcomes of these separations were dramatic. Isolation created conditions for speciation, as populations cut off from one another evolved independently. Madagascar's lemurs, Australia's marsupials, and Kerala's lion-tailed macaques are all products of this process. Climate shifts driven by continental positions further shaped ecosystems, producing deserts, tropical forests, and alpine habitats. Marine biodiversity was also transformed as new coastlines and currents altered nutrient flows, giving rise to coral reefs and fisheries. Each fragment of Gondwana became a cradle of endemism, with species found nowhere else on Earth. Kerala's Western Ghats exemplify this Gondwanan legacy. The crystalline rocks beneath Vazhani, Peachy, and Chimney belong to the same Precambrian belts that extend into Madagascar's Ranozara zone. The forests of the Ghats, rich in orchids, endemic mammals, and freshwater biodiversity, echo the rainforests of Madagascar in their structure and evolutionary history. While Kerala's granite quarries have yielded minerals such as quartz, feldspar, and garnet, Madagascar's crystalline belts concentrated gem-quality corundum, tourmaline, and beryl, making it one of the world's richest gem sources. The geological kinship is clear, but the distribution of gem deposits differs, showing how continental drift shaped not only ecosystems but also mineral wealth. Continental drift is therefore both a geological and biological narrative. It explains why Kerala's Sayapavata is a biodiversity hotspot, why Madagascar is a treasure house of endemic species and gems, and why Karur in Tamil Nadu hosts rubies and sapphires in granulite belts related to those in Madagascar. The restless movement of continents fractured Gondwana, but in doing so it created the conditions for life to diversify and landscapes to acquire unique identities. The forests, rivers, and rocks of the Western Ghats, alongside the rainforests and gem fields of Madagascar, remain living records of this ancient drift. Peachy Vazhani Chimney in Kerala and the Ranozara zone in Madagascar share Gondwanan roots, but their biodiversity and geology diverged after continental drift. The breakup of Gondwana between 180 and 90 million years ago set India and Madagascar on separate paths. India drifted northward, colliding with Asia, while Madagascar remained isolated in the Indian Ocean. This isolation explains why the Western Ghats of Kerala and the crystalline belts of Madagascar retain geological similarities but host distinct ecosystems. The crystalline basement rocks of Peachy Vazhani Chimney, composed of condolites, charnokites, and quartz feldspar pegmatites, are part of the southern granulite terrain. These rocks are structurally continuous with Madagascar's Ranozara zone, which geologists describe as a piercing point for Gondwana reconstructions. As Georgius and colleagues note, before breakup of Gondwana, its general position is thought to be in between eastern Africa and India. Lateritic soils in Kerala, formed from tropical weathering of these ancient rocks, find their counterpart in Madagascar's red soils, which developed under similar climatic conditions. Both landscapes thus share the same geological foundation, though Madagascar's crystalline belts concentrated gem-quality corundum, tourmaline, and beryl, while Kerala's quarries yield mainly granite, feldspar, and garnet. The Kuthiran tunnels, carved through the Western Ghats along NH 544 between Thrissur and Palakkad, cut directly into the southern granulite terrain, exposing hard charnockite and gneissic rocks that form the backbone of Kerala's uplands. These twin tunnels, each about 1 kilometer long, reveal the toughness of the crystalline basement that once linked India with Madagascar and Africa in Gondwana. Driving through them is not only a feat of modern engineering but also a passage through some of the oldest rocks on Earth, where the road slices into billion-year-old metamorphic formations that define the physiography of the Palakkad Gap.